Well, hello there guys. Hope you're doing really well today, and we're going to have a very interesting look at the way we calculate the distance, the straight line distance between any 2 points. Okay, so let's go. Actually, it's all about dear old Pythagoras, who's really made a name for himself, didn't he, in maths? So that's what we do. And I will show you. The distance between 2 points can be calculated using Pythagoras' theorem. Yes, it can. So we consider 2 points. A, which I'm going to call point 1, which therefore is x1 and y1, and B, which is going to call that point 2, which is x2 and y2, on the Cartesian plane as shown. So let's have a look at that. Let's make that point A and that point B, and therefore we've got A is the distance AC is this horizontal distance here, guys. Now, if you analyse this, the x-coordinate of C will be x2, and the x-coordinate of A, of course, is going to be x1. Therefore, this horizontal distance AC is basically x2 minus x1. It's just the difference in the x-coordinates. That makes sense, doesn't it? And similarly, the y distance, the BC, the vertical distance from C up to B, is basically y2 minus y1, because this y-coordinate of this point is y2 and the y-coordinate of this point is y1. So that's what we get, right? Now, I'm setting this up for good old Pythag to come and entertain us with his theorem. I've got a little triangle here, a right angle triangle, ABC, with a right angle at C, and you know, I know you know, that Pythagoras' theorem says that AB squared, the square on the hypotenuse, equals the sum of the squares on the other two sides, which are of course separated by a right angle. Yes, formed with a right angle between them is what I'm trying to say. Yes, and that's the formula. That's the formula. Even though it looks a bit yucky, it's just basically now a matter of plug and play now, guys. But we better first take the square root of both sides and just get the for AB, not AB squared. So AB will be the square root of that stuff, like that. And therefore we'll put a big nice box around all this, and that's our formula that we're going to use. The distance between 2 points, A being point 1 at x1 and y1, and point B being point 2 at x2 and y2, is this. And that's all it is. That's all there is to it, guys. So let's go with that and we'll see if we can do some. What do we got here? The distance between the points A and B in this figure. Look, no problem whatsoever. We will work out, why don't we call this one, what should we call that? Point 2, I suppose. And we could call this one point 1, and then we can just use our formula. But first we better work out what x and y are at both those points. Well, that looks like 3, x is 3, and y is 4, doesn't it? I think so. And here we've got x is minus 3, and y was plus 1, wasn't it? Alright, so therefore now we're spelling it all out so we won't mess it up and make a mistake. x1 is minus 3, y1 I mean is 1. Now let's go over here. So x2 would be 3 and y2 would be 4. Now it's a matter of just plug and play the Pythagoras way. Today, hooray, and we say that the distance is this. Come on, we're going to plug and play now. So, now this is a bit of a booby trap. Look, 3 minus, now look, wait a minute. So we've got 3 here minus negative 3, right? 3 minus negative 3. So I put that negative, whenever I'm minusing a negative, guys, I think it's time to be very careful. So I put that in a bracket. I don't do it straight away for fear that I might get it wrong, and I do it in the next line, right? 3 take away negative 3, all in brackets squared, plus 4 take away 1. There's nothing wrong with that one. No danger in there at all. Now come on, next line. Do you know what 3 take away negative 3 is? And don't say 0, because it isn't. Basically, it is 3 plus 3, which gets you 6, doesn't it? And you can see, look, the distance between this point, this x-coordinate here at 3, and this one over here at minus 3, it's not naught, it's basically 6. They're 6 units apart. So the maths has saved the day, hasn't it? And we got the right answer for that. 4 minus 1 is just 3, so here comes the next line. So, okay, the next line is mighty fine. And we're going to get the square root of 36 plus 9, which is 45. Now, doing some surd fiddling with that, 45 is 9 times 5, and 9 is 3 squared. Okay, so that's his ticket out of jail. If he's a square, he comes out of surd jail as just a 3. And we've got 3 root 5 to keep us alive and help us to thrive. And if you did that on the calculator, guys, because they didn't actually ask us if they wanted it in exact surd form or as a decimal thingy, so we might as well give them both. If you did that on the calculator, you would get 6.71 to 2 decimal places, and you'd be correct. And you'd be laughing. Now, look, you use this Pythagorean theorem whenever A and B, the line connecting them, is on any kind of has any kind of a slope associated with it. Now, if it's horizontal between A and B, which this isn't, you just do the difference between the x coordinates if it's a horizontal line between A and B. If it's a vertical line between A and B, then you just do the difference between the y coordinates. But if it's anything like this, where you've got some slant on the line between them, some slope, some gradient, then you have to use this Pythagoras thing. Okay? Yes, that's what you do. Okie dokie, what's this thing? Find the distance between the points. Well, they haven't given us a graph for this, so I think we will just go right ahead and label one of them 0.1 and the other one 0.2 and just use the formula anyway. Yes, let P be 0.1, which would get us that, and therefore x1 would be, you tell me, and what would y1 be? Yes, x1 would be minus 1 and y1 would be 5. Good show. So, yes, I've written it all out very, very simply so that we can't mess it up and get all overwhelmed with trying to do these things. In our heads, it's better it's down on paper than in our heads so we don't make a mistake. Now, Q, oh yes, the 0.2, okay, so that's we're going to call that 0.2, so that's going to be that one, and it's the actual point there. So what's x2, what's y2? Come on. Yes, 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 sir. So there we've got x2 is 3 and y2 is minus 2. Now, come on down, Pythagoras. Here we go. And we've got this formula. So come on, we just plug and play. x2 is 3 minus, watch that one, minus negative 1 all squared plus negative 2 take away 5 all squared. Now let's see if you can do this. What's that going to get us, guys? Is it 2 or is it 4? What is it? It's 4. Yes. And this one, what's this? Minus 2 minus 5. Come on, they're both on the same team. They're on the minus team. So how many of them are there? There are 7 of them on the minus team, so it's minus 7. So there we go now. Okay, so that's going to be 4 all squared, which I reckon is 16. Now, what is this minus doing here? What's that going to do to us, guys? Minus 7 all squared. So minus times a minus, we're squaring the minus and we're squaring the 7. So minus times a minus gets us a plus. Good, good, good. And 7 times 7 is 49. Excellent. That gets us that. And what do we, yes, so 16 plus 49, well, I could call that 50 plus 15, couldn't I? Add 1 to there and take 1 off there. And 50 plus 15 to get us 65. Now, that little beastie doesn't have any guys to get out of surd jail because that's just 5 times 13 and they're both primes anyway. So I think it's time for the calculator just to get the decimal thingy of it because the surd can't be simplified anymore. And what do we get? 8.06 it looks like to 2 decimal places. Absolutely excellent. Alright, we're cooking along nicely here. And what else have we got? Right, prove that the points A, B and C are the vertices of an isosceles triangle. Well, that's a little bit clothed in mystery, isn't it? I think the best thing for you and I to do here, to work out what on earth they're talking about, is to draw a picture. And a picture in maths is a graph. Okay, a graph will alleviate the pain and possibly give us the way forward. I think it will. give us the way forward. Now, vertices means the corners, right? And what's an isosceles triangle? Do you know what that means? Well, it means that two sides of the triangle are equal in length. Okay, so come on, we're going to draw this. There's the thing, there's the scale. Now let's put the 3 points on it. We'll go for A. That's 1 and 1. Hello, Mr. A. Now, B is 3 and minus 1. X is 3. Y is minus 1. There she be. That's Mr. B. Yes, and what about Mr. C? He's minus 1 and minus 3, so he's over the other side down here somewhere. Let's see now. Minus 1, minus 3. Very good. Now, let's join them up now and see what we've got in the way of a triangle. Ah, excellent. I think B, C, and AC are the candidates for having a look at the side length between them. The length, the distance, e.g. the side lengths of this triangle. If we can prove that the length of AC is the same as the length of BC, well, whoopee! We've proved that's an isosceles triangle, haven't we? So come on, we'll do it. Oh, there's all my points to make it very clear what I'm doing. Now, looks like, yes, it looks like AC and BC are the candidates. Four sides of equal length. Let's work it out. AC, okay, now it's the Pythagorean thing again. Thank you, Mr. Pythagoras. Take it away. Oh, I've labelled all this, very, very specifically, so I don't make a mistake and get overloaded in my working memory with too much of this stuff, because you're not all that familiar with this at this point, but you will with practice. You'll get really good at it. So let's do that, and let's plug and play. So there it goes. That's the formula. Now we just plug all those values in for points 1 and 2. Don't we? Yes, we do. So there it goes. Now, what x2 was minus 1, x1 was 1, so that's right. Minus 1, minus 1. y2 was minus 3. Take away y1, which was 1. That's good. Now, we've just got to deal with all these pluses and minuses and everything all over the place here successfully, guys. This looks like, what is that one going to be? Minus 2 all squared, yes, and this will be minus 4 all squared. Now, remember that the minus, when you square the minus, that just becomes a plus, so it looks to me like 2 squared, which is 4, plus 4 squared, which is 16, so I reckon it's root 20. Beautiful. Now, if you do some surd fiddling with that, you'll realise that 20 is 2 squared by 5, which means that this guy's got a ticket out of jail, so he can come out of there as just a 2, leaving poor old 5 in there with no hope of getting out until another 5 comes and rescues him sometime in the mathematical future. We're just having a bit of a joke with that. But that's basically the length between A and C. Yes? Let's do the same thing for B and C now, and hopefully we'll get the same thing. Because if we do, we've proved what they asked us to. Okie dokie. I've called that point 3 because we've already used up the names point 1 and 2, but that doesn't make any difference. We'll just do the formula for 3's and 2's, shall we? Yes, I'll show you. There it goes, see? x3 minus x2 all squared plus y3 minus y2 all squared. That'll do it. Now, we've got to plug and play now. This looks a bit dangerous, doesn't it? And so does that. Goodness gracious. Okay, look. 3 take away negative 1 is 4. Minus 1 take away minus 3 is also, that's minus 1 plus 3, and minus 1 plus 3 is plus 2, alright? There it goes now. Okay, so that's going to be square root of 16 plus 4, which is 20, and I feel great because that's what we got up there for the other one. So that's also 2 root 5. Now look, how marvellous. This is the same as that, which means that those sides are the same length, and we've just proved it. AC equals BC, and therefore the triangle ABC is indeed isosceles. Give yourself a pat on the back. Yes, you've done a marvellous job. I think that might be it. That's our summary. That's our summary of use of the formula that we have to use for the distance between 2 points. Yes, for anything except horizontally and vertically displaced points, that is the formula we have to use. Okay? And I think that's about it, guys. And you are a star and huzzah, and you'll go far. So, go forth and multiply your mathematics and Have a wonderful day, and I'll see you next time. Bye for now.